Welcome to Dialogue, a podcast where we unravel the threads of technology that are shaping the future of our world. We discuss technology and software both on high level and under the hood.
My name is Lauri Jutila, and I'm the CTO at Finitech, the leading freelancer tech talent agency in Finland. And I'm your host on Dialogue, where I'm interviewing top professionals in their fields, so as a software expert, you might not want to miss this. Welcome to Dialogue. My name is Lauri Jutila, and today we're delighted to have Markus Schirp with us. Markus helps developers and development teams to write better software, and he's a well-known figure at least in the Ruby community, being author of a very popular, or at least I think very popular and very useful library called Mutant. He'll probably show and tell us today how Mutant works, but welcome to the show, Markus.
Yeah, thanks for having me. Small correction, it's not a library, it's a tool. So because it's executable by itself. Okay, yes, sorry. Exactly. Yeah.
But can you give us a little bit of brief background on who you are and why should people listen to you?
So I'm basically a freelancing software consultant. I've worked in various industries, and right now I'm with a finance client mostly. And I've got a little bit of an itching each time I see developers going through cycles where tools could be assisting to make them more efficient. And over these, let's say, 2 decades I'm doing this, I serialize lots of these things in tools, and some are publicly available. And part of these tools is the Mutant thing you have just mentioned. And yeah, so basically my mode of operation is that I go into teams, find issues, solve issues, and keep some tooling ideas, or sometimes even some tools I create on and just build them up over time. And some of them I can release, some of them I can't release, and so on and so forth. And Mutant is a relatively old tool of mine. Another correction, I do not think it's popular. It's just known that it exists, and it's lots of people know Mutant exists. Not many people have tried, and this is also because of the history of the tool. Because when I write these things, I write them for my teams, and they used to be fully open sourced, but I didn't really care about making an onboarding ramp simply because I wouldn't have the time to do that. And this is a relatively niche topic, so it was lots of self-selecting. So there are people onboarding themselves, but these are quite dedicated individuals. And I think around 2 years ago, I decided to buy out all the other contributors and put the tool into a commercial mode. I'm still way too busy with my consulting, so I didn't spend too much time on improving the onboarding, but it's getting better. I think we both talked 2 or 1 year ago on Twitter DMs about the tool. And now you invited me to the podcast, and I'm happy to have another reflection area for my thoughts on that.
Yeah. Well, so why I wanted to have you on is obviously the tool itself, but also like the what it can do for a developer or for development teams. And you probably have other tools and ideas that we can share today with the audience that so hopefully will make them write better code and do less, as you said, less boring stuff and work on
exactly
the valuable things.
So let's first get exactly. So Mutant is right now a tool exclusively for Ruby, and in my mental model of languages and how they stack up under what business constraints you would use Ruby. Ruby is a language you use when you have a Ruby team, but you wouldn't, at least from my perspective, I would never start a greenfield on Ruby because Ruby. I just do Ruby because it exists and there's business there. I do not particularly like the language. I've got lots of issues with the language, but this is not the point. When I'm going into a business, there is Ruby and we need to deal with Ruby. And it's all about, so when you think a typical developer cycle, a developer does something, writes in his editor, saves the file, and in theory you could just ship it to production. But the chance that you just save something, you can ship it into production, doesn't cause any damage, is quite, so this chance is quite low. So we have every team has a different process here, but there are a series of checks where this change you just did get filtered. The first level is, does the thing parse? So does the Ruby interpreter say, this is at least Ruby I could execute? The second step is, eventually, are there any automated tests? The third step is, does it pass code review? The fourth step is, does it pass acceptance testing by the customers if you have a stage? But there is basically a funnel, and this funnel is just taking out saves you did in the earlier thing. And all I care about as a software consultant when I go into optimizing teams is to increase the cycle time. Decrease the cycle time. Cycle time is measured from time of saving the file to time of saving the file again, and eventually have been doing something better. So I need to preserve the most expensive things in this funnel as best as I can. And one of the most expensive thing, which is still valuable because we do it, is code review by humans. And especially in Ruby, you have lots of situations where you ask yourself questions like, let's go into the shell for a second. So let's say you have a call site like, you have something like foo.2s in your code. And as a reviewer, you need to ask yourself, so is this foo originally a string? Is this 2s call actually required, or is it just in case code? Was it required at some point? And all you can do in the end, you can stare at the code, but it's a dynamic language. There are no types. You could just remove the 2s call and just run the tests again. And then say, oh, probably it's not required. But then you do not even know if the tests elaborate all the cases, like if all the cases where foo is a real string or just an object which quacks like a string. So all I need to do is to figure out a way that someone being faced to review this call site has to spend the least amount of time on things only a human can decide. So we have no type system, at least no native one. There is Sorbet, but it comes with, this is another local optimum. You could just say, oh, we go full board Sorbet, but onboarding Sorbet to an existing 5 million lines of code Ruby thing is also not an easy feat. So we need to do something incremental. So and all I thought what I did very early in my code review career is just delete this call and ask the test. If the test would detect that the 2s is missing, I would say, oh, probably it's all right. If it wouldn't detect if it's missing, I need to ask myself, okay, was this redundant code, or did somebody forget to write a test to actually pass an object which is not a string where 2s actually has some important semantics to trigger a coercion? And typical PRs are 500 lines of code, 100 lines of code, depends on the team. And this can become quite tedious. And also, the next thing is, let's say I've verified right now that we have a call site like this, and the 2s is required right now, but I've got a flag somewhere else in the code where the developer has to change something, goes back in 2 hours, pings me again. And in theory, I have to recheck everything.
Yes.
But I won't, because I'm a human. I'm biased because I just saw the PR before, and I only had this flag 10 lines below, and I'm not rechecking this one. And given enough time, I should probably have rechecked it, because maybe something else changed meanwhile, and this 2s is just dead code. Dead code is actually still a very good outcome. Deploying dead code is not as bad as deploying a bug, but hey, that code can easily turn into a bug, because what if the next PR actually passes something where 2s is wrong, whatever. So all I need to do is to figure out a way to automate these kinds of things, where I can just say, okay, so I've got a hypothesis, this call is not required. Can I automate in some way, write a stupid chaos monkey which deletes all call sites and checks if the test notice? If a tool could tell me I can remove this call and the test do not notice, the tool cannot do much more, but it's still a big help for the reviewer, because the reviewer can then be highlighted. There is wriggle room between the semantics of the code I'm going to push to production and what the tests demand. Often it's benign. Often it's actually just dead code, but in many cases it's actually something important where a test is missing, or the code simply did something the test didn't demand. You should probably never deploy it in the first place. And let's go to something more fun, like so that's something way more interesting from a business logic perspective. Traditional line coverage wouldn't tell you if you actually did this branch. Traditional branch coverage could, but now let's go for a more fun thing. Do Okay, let's go for an editor. So let's assume that do eligibility check leaves some state behind, where apply promotion if eligible would pick it up. So there is no branch visible here. So a traditional branch coverage tool couldn't do anything for you, because there is no way it could see through that there is actually some kind of state being written here, like, or something. Okay, so what I need to do as a reviewer need to be sure that both call sites are actually covered, that the semantics of this call site are covered. And I could manually go in and just delete this, rerun the tests, and then say, okay, the tests failed, so probably this deletion is covered. So probably this code on this specific property is good. Or the tests do not fail, and probably the case where the promotion is eligible is not covered. But this is something I, as a human, have to do. But at scale, if you review 20 PRs a day, you will never have the discipline as a human to do it. Maybe you have the discipline to do it on the first iteration of a PR, but if you find a small flag, you are not going to recheck everything else. And all I wanted to do with this tool is to automate this process. I wouldn't say fault injection. So this is not fault injection. This is injecting a semantic reduction and simply asking the test, can you check this? And when I review code and I know this automated tool went through all these cases already, then I can focus on more interesting stuff like, what is the promotion ability check actually doing? Does this comply with my customer's requirements on when a promotion is eligible? Versus, do we actually check for eligible promotions? Because this is more boring. So all I want to do is to have people in my teams spend the most expensive resource in software development, which is developers' time, on interesting problems. And that's how the entire idea of these kinds of tools is born. So think of it as a chaos monkey, but it doesn't just randomly add code, but it simply tries to make the code do less and makes a test proof that that the test actually demands this logic. And you can do quite interesting things here. So it's time for you to say something, because I'm on a monologue for 10 minutes.
So who is this? You said that this is for the code reviewer, but would you say that the regular developer should be running also?
Developer also itself. So in my world, in my mental model, you are your own code reviewer. You're the first line. When you write code, you are your own code reviewer. You should only ever submit something which would pass your own review. But because we humans are flawed, we do the second one. I'm not super biased. But I would use the tool by myself in the first pass, and I would never send someone else a PR merge request to review if it wouldn't pass this quite easy to automated reduction check if I actually covered all the semantics in the code which the tool can reach. And it's in my development loop, obviously. So I have my editor on the left, my Firewatch on the right, and it runs this tool on all the changes all the time. And I have it on my CI. I have it. All my coworkers are using it. Actually, they're not using it because the CI would be red if there is in a live one. But this is you do not have to start full bore with this thing. You can just start. You can say, oh, I only use it for reviews. I only use it for reviews of other people's code or my own code, or I only use it on CI. I do not prescribe anything. What I'm caring about is to push boring checks to the machine. We do not have a type system. Type systems are quite elaborate things, but they are quite boring checks. And there's a reason type check is a system. We're not checking types by hand. And in Ruby, we do not have a built-in type system, so we need to do something else. So people say, just write tests. Okay, nice. But how do we know that the test actually covers the semantics? Use code coverage. This one could easily have, if you just write one test case where the promotion is not eligible, this is 100% code coverage, 100% statement coverage, 100% brand coverage, but just 50% semantics coverage. And semantics coverage, to my experience, you can only measure in simply doing these kinds of hypothetical deletions. So the tool would go in and just say, bam, run the test again. And the test case where the promotion wasn't eligible would still pass. And the other one is missing. And we could move over to where I show you some stuff with the tool, but I wanted to do it.
Yes, that would be great.
So that's a little library I wrote, and I just asked it to do a full pass over the library. Let's first talk about what the library does. Basically, it's called algo with units of measurement. So you just say, I've got 1 meter, I'm dividing it by 100 meters, and you get a unitless value back. So it tracks the units. It's a thing I wrote years ago for a specific use case, and it does all the things you would ask it. So this it knows that this is square meters and so on and so forth. So, and this library is my standard candle for mutant development. So I require that. I know it's 100% mutation covered on the previous mutant version, and if I might a new mutant version, it still needs to be 100% covered.
Right.
So let's do something redundant here. Let's just say we, for some random reason, did this code edit. So this is that code, because anything times 1 is still... Okay. So now I'm using a full pass still, but it still is able to tell me that if we change this code to that code, removing that multiplication by the unit, by the multiplication unit, this doesn't cause test failures. But it can't do more, but it's still very important for me. If I were to review a 100 lines code diff now, I could still zone in and say, hey, is this a missing test case, or is it just that code? In this case, it's that code. And I would normally not run it over the entire library. I would just say, target everything which was changed.
Yeah.
By telling it to, and then it's pretty fast, so you can't really complain about the speed. It's faster than running the entire RSpec suite because it just focuses on the specific thing. So all it does is trying lots of hostile changes. So it actually tried 55 ways to screw up this code, and one of them didn't cause a test failure. And you can go arbitrarily deep here. So if we were to, I'm not playing Ruby interpreter here. Let's find. So it's not like Mutant knows much about what. Let's go. Even if it were indirect, it's still detectable. So it still knows that even if it's indirect, it still knows and even the entire call site is wrong. And these are interesting cases because people tend to nest or chain function calls, and we can still take out stuff from the chain. We can take the parent call out, whatever we want. And this was the amount of, we call these things mutations, and there is a giant library of possible mutations, which are all written under specific guidelines, and I can go into these later. Yes. But basically, I've been assembling each time I had a bug in production. I would go back. Okay, so it was missed by human review. Fine, human review is flawed and fuzzy anyway. So, but could we have done a change to the code which demands us to either not write this code this way or have a test case where we would probably have found the contradiction we deployed? And then we would go back and ask, okay, so is there a code change which would have triggered an alive mutation, which shows us one of these diffs where we could have been asking ourselves, are we actually doing the right thing or not? Yeah, and that's basically the genesis story here. And then apply 10 years of development to it. And here's a tool, but it has, as I said, it's the onboarding is still terrible. So it's not really hard. The config file. The config file is not really hard. So the problem is more that you need to have this kind of semantic reduction mental model to make sense of it. So people still come to me and say, Markus, what does this tell me? And for me, I just say, yes, if you were to change the code you have right now to this, then no test fails. And then people ask, but what does this mean? Yeah, it means that either you're missing a test case or your code does something you do not need, then just delete it. And on mature code bases, it's very often the second case. So it's not about discovering missing test cases, it's about actually making your code only do what your test cases demanded and nothing more. And for people who work with me for several weeks, I've got zero issues to get them started here also on complex cases, but I've yet failed to make any kind of documentation somebody could self-onboard for more complex things, when it goes into databases, when it goes into testing RPC and so on and so forth. It's entirely possible, and it has a really nice return of value, but it's not easy to wrap your head around, because as a developer, you get raised in a different way. You think about the code or the tests, but never about the. I try to explain it. When you build a house and you do a concrete thing, you have a cast for the concrete, and then you pour concrete in. And if you have a big concrete structure, you would rattle it a bit so it settles. And the mutant is actually this rattle thing, where we try to make sure, is there any kind of small hole where there's still air inside, where there's a little bit of wiggle room, and all it does is to show you this wiggle room. It can't tell you more, but this is already way more scalable than any human discipline would ever take you. I've worked with people I call code review machines, but when they can have a bad day, and this thing cannot replace this code review machines, but it can do 80% at a fingertip. So, and then I can use this person, and if he ever hears this podcast, he knows who I'm talking about. He also turned out to later be a big fan, because I can remove 80% of all of that doing, because I know this thing is covered.
So how would you instruct a developer to learn more about the actual, let's say, not maybe mutant itself, but this way of thinking? So what would be, how would you approach it as a new developer?
We can talk about axiomatic development for a second. So,
okay, sounds good.
Given the same problem and the same rulebook, a good rulebook results in two developers not talking to each other, ideally, in the perfect case, which will never happen, come up with a bitwise equivalent code. That's the ideal case. But I do not think we will ever reach this, but this should be our guiding principle as a software community. So, and all we can get is to reduce the difference between these two solutions to a minimum. And it will still be quite large, but the more you subject yourself to not just use your own personal style or some other more subjective arguments, the more sustainable and incremental and also more combinable parallel development gets. And in a bigger team, consistency is often way more important than any other property, because we can never prove a system correct, but we can prove a system consistent. And when we then later figure out that the system actually has incorrect behavior, moving inconsistently wrong to whatever we think, moving consistently wrong to consistently better, I never say right, because we never know what right would be in a bigger project, is very simple. But moving inconsistently wrong to inconsistently better is really hard. So in the end, you, as a development team, you need to subject yourself to rules which allow to settle cases. And we discovered in my teams that there is a rule of use the least powerful primitive that does the job for anything.
Right.
You can, if you had two options, let's make a very, very stupid one. So that's a very powerful primitive, a case statement, but that's more powerless. So if we were to branch on any kind of condition and use a case statement when the condition only can have two values, then we're using a primitive that can do more to just do a small thing. So we should use the least powerful primitive that does the job on all levels. And when you look at two statements, what's simpler than two statements? Yeah, simpler is one statement or the other statement. So these both are semantic reductions of each other. And this one, the branching on if is a semantic is also a reduction of the case statement. And this is how we define mutation operators. So you can only take a mutation operator from a primitive which does many things to one which does less things.
Yeah.
If you were to make a truth table, so think of when we all went to computer science, we had these kinds of, so XOR has this truth table, whatever. You can only ever kill a row or a column but you can never add a column or something. So your decision-making rules should always force use the simpler thing unless you have an example where you actually need to use the more complex thing.
Right.
And if you apply this consistently everywhere, the variance between two developer solution reduces by, let's say, 50% already, which is a big thing. And if you then use tools which always force you to use the least powerful encoding of something, because if we were to look at this example, what's simpler than multiplying a value by 1? You're not multiplying it by 1. So you can always use this kind of Occam's razor to cut down the code to the absolute minimum. Yes, there are local optimums, so you can express it. You can express there are situations where you have two ways to write things, and you cannot strictly go from one way to another. But at least you're in this local optimum already, and you at least you're not carrying all this redundancy. And then this is then where the human reviewer is again. But we should delegate everything else we should delegate everything else to these kinds of axiomatic decision making. And this is the kind of mindset where this tool was born in. And you can apply it also to syntax. So let's say we have the decision to use this syntax for the string or use what syntax. It's quite simple. The single quote one can't do escapes. Unless I do an escape, I shouldn't use it.
Right.
Case solved. This is not style. This is just axiomatic decision making. I know many people say, but my style, I prefer. So as soon as I hear prefer, I'm out. This is not about, because we can argue about preference 100 years and we will never ship anything. But I typically say, eat your pride. Just you should have your pride in applying this axiomatic decision making and not your pride in I've done it 10 years wrong. You should be actually proud that you can recognize you did it 10 years wrong. Yeah, so this is how I try to cut down these kinds of discussions significantly. You can apply it to SQL statements. You can apply it when you do a join. If you do a join on true, you can just use a cross join because the on true is just redundant, and so on and so forth. So you can do it to architecture decisions. And yes, there are always situations you cannot strictly go from Lambda to EC2 or EC2 to Lambda, but at least within EC2 you can make it simpler.
Well, that's a really powerful way of thinking. And are there any other guiding rules that you wish that the teams that you work with adopt?
Yes, but these are all delegates from this universal rule, like uses least powerful primitive unless you have a counterexample. So we can go into examples if you wanted to on how to apply it, and sometimes there are lessons learned, but this is then go specific to the technology and instead of the overarching thing. So we could go back to Mutant and discuss some of its mutation operators in the light of this decision-making tool.
Well, let's do that. So there'll be a good example for people.
So perfect. So this is just running the mutation testing engine without filtering the results with tests. So if we look at the expression calling bar on foo, the more powerful. So what is less powerful than doing that? It's just returning a constant nil. Okay, that's one. Then not calling the bar method. So we just have foo, and we could just argue foo is always relative to the current object. So let's replace so any method call which is unqualified is just a method call on the current object. So actually the chains always start with self. So let's also ask the code to prove that we cannot do this simplification. Let's go for more examples. Let's do a little bit of let's do literals. Again, you can replace every expression with just the nil, which is the most primitive data type in Ruby available. And these are a little bit special because you cannot really argue that 1 or 0 or 1 or 2 are actually more or less primitive. It depends on the context. So for addition, 0 is more primitive. For multiplication, 1 is more primitive. We call these orthogonal replacements. These are not strict reductions. These are just very common boundary tests to make sure that people actually when they have a literal in their code, they actually have a test to verify that they do boundary checking correctly.
Yeah.
So I would argue that these do not fall under primitive reduction. But let's do more cases. So we can argue, okay, so we have a function call, we are passing bar to foo, and we can argue, okay, so what if foo will have a return value, and the expression, we can just replace the return value with never calling foo in the first place. If foo is some kind of validator, filter, whatever, it will force us to actually have a test to, the code could have been looking like or sanitize, yeah, it's my stuff like that.
Mm-hmm.
And one of the more important ones is actually to verify that we are sanitizing. Okay, so and this comes all back from these are coming all back from this semantic reduction axiom, where you say, okay, so I need to use the least powerful thing, and what's less powerful than calling sanitize on bar? Actually, I showed you the wrong one. This one is the one where we kill the call. It's just directly using bar. It's using less semantics. If you were to make a truth table of this entire thing, we are just removing entire column where we actually did the sanitizing. And I need to prove to the system that they actually care about it, which is just one test where the sanitization would be at work. I do not think sanitization is ever a good idea for input validation, but this is an entire different topic. You should be parsing, not sanitizing. Yep. Let's go for more. We can do more special cases. So that's a method definition, and originally this method does a sequence of 2 actions, but we can replace it with arrays. We can replace it with doing the super implementation. Maybe it's the same, and we shouldn't have written our own version. We can remove the both things to the implicit nil. We can just say, okay, so we are just doing the B, and so on. These are all coming down. These are all automatically checked rules for the developer. So a reviewer or even the author himself doesn't have to do it.
Yeah, and these are really good examples for, I can tell from personal experience, it really helped me to figure out the test case coverage that I have to have in order to be certain that the system does only the things that I want it to do, and also actually drives the code to be a much more, as you said, you remove the dead code and you remove the you express things in a more simple way.
Exactly.
And you, again, using the axiomatic development principles. So, but let's say people who are listening they think this is a great idea, but they are not Ruby developers. So how does the tool landscape look for other programming languages or paradigms in general?
So there are many other tools for many other languages, and many of these tools are not as mature. I think only the tool for Ruby is mature, the tool for Java, and the JS one, whereas I haven't checked out the JS one in a long time. And these kinds of tools, so there have been lots of papers over the last 50 years, and these came all from academia, and they all said these tools are slow, blah, blah, and so on and so forth. But they were never written by people from the industry who actually have to optimize for throughput, where the academia people are way more interested in perfect accuracy. So it's a typical 80-20 problem. It's more like a 99.1% problem here. So if you accept the tool's coverage to go a little bit lower, then you can make it so fast that it typically, even on CI, finishes before RSpec.
Right.
Simply because it runs only a small subset of tests.
Yeah.
Because you would simply scope it to only what you have changed, which leaves anything else which depends on your change open, fine, if you accept that, but it's still much better than any reviewer could do consistently. And
one thing you did mention you wanted to preserve the most expensive resource in that development cycle.
Exactly.
Whether it's and now if we do increase the use of or the cycle time of the single developer, but significantly reduce it on the other steps, maybe on the most expensive steps. So if if the code runs a little bit, or the development cycle or testing cycle is now 5 seconds longer than usually or previously for the developer, but it saves 10 hours on the code review and CI side and so forth.
Exactly.
Totally
exactly. If that even were the case. So using these kinds of tools correctly with the incremental mode, I can just go back to it. So this is a very simple code base which boots very fast. Let's go not with internal measurement, let's do an outside one. So the full boot was like, the entire thing was 1.2 seconds. We cannot really complain about that. Yes, typical rates boot like 4 seconds and then all this stuff, but it's not more expensive than a regular test run. That's if you use an incremental and accept the fact that if something is unchanged, which depends on the code you have just been changed, it will just run the test and not the automated reduction thing, which is a good trade-off. I don't mind, but if you look up any kind of resource on mutation testing, you see all the blog posts start with, okay, so this is a really good idea to increase the coverage and confidence, but it's so slow, we should probably never try it. It's like, yeah, okay, but you probably have read the only paper 20 years ago, or you tested the tool for, let's say, I do not want to badmouth any tool, so let's use the programming language where there's definitively, let's say you tested the mutation testing tool for whitespace, which doesn't exist. Whitespace is one of the fun programming languages, and it doesn't have this optimization, and then you say, oh, it's just too slow, and the entire technique, it's super nice, but it's unusable. This is what you see in most blog posts. So they are very happy, and then, it's just too slow, we cannot never use it. And just check it out, people. If you look for the 3 mature tools in the space, then this is not an issue, because you can do the trade-off to simply not test everything and just test what you have changed. And as soon you did that, fine. Which also has a nice effect. Let's say you found a mutation in a method you haven't changed, and it's in production for 10 years. Who would want to fix anything there? You cannot go to your project manager and say, hey, we have got 10 alive mutations there in a code we are not touching. It is irrelevant information. What you care about is there something in the code I'm touching right now? This is where you can spend development time and where it's totally acceptable for the business and for your coworkers to spend the time on.
And again, if you're not, if you can avoid triggering the extra code review or extra few hours of code review by running this, it's totally worth it for any development.
Exactly. So the issue is, if you were to look into the space as a developer, you need to be lucky that your first experience is one of the good tools, and then you actually read the docs to the point where they talk about incremental mutation testing, because you have to opt in. I do not know what your branch. I do not know your branch naming scheme. I do not know what's the best reference. You need to tell the tool, and until you did, the tool simply does the pass over everything, and then it's obviously too slow. Which maybe I should simply say you have to explicit. Maybe I should make. I think this would be a good idea. I should probably change mutant to say this argument is required. And if you wanted a full pass, you need to pass a separate argument. And this way, people do not bounce as early. Thank you for this. This is perfect. Yeah. And I will make it mandatory for all other mutation engines, testing engines to do the same. So do not release it to Hacker News unless you make incremental mandatory.
All right. But if we talk one bit of the development cycle, the code reviews, what are your in your experience, like the guiding principles that if you want to do good code reviews, what you should be, how you should approach pull reviews, and what things to look at, and how to comment the code and so forth.
So I'm going so far that I would only want to approve code on a code review if it's up to my own standard, and if it's written in a way I later look at the code and say, this is my code. But for this, you need to have these kinds of axioms which reduce all the personal idiosyncrasies. And I do not think that many people in the industry can do it that way, but I only think this is not inherent. It's more like this industry is way too young. If you go for, if you look at the medical industry, the gold standard is a double-blind study. So if you do any kind of medication and you didn't do a double-blind study, people laugh you out of the room. And I hope that we as a software industry will be there. And if it's the axioms or something superior, I do not mind, but we do not have these kinds of guiding principles, but we should have them. And, so I do not think that most people would be able to do code review the way I like it when I say I only merge stuff which could be written by myself. But this is only because I subject me and my teams to these kinds of decision-making tree where we reduce these variants. When I do open source contributions to someone else's code, I have to infer his decision making to make it look to fit his style. But as soon as I use a style argument, I get a brain lock up simply because of the way I've been raised as a developer, because the first thing I would try to remove is style, because once we start doing a technical job on subjectivity, we end up with submarines which do not surface anymore.
Yeah, so, the interpreter or the compiler, they don't care about your style, right? They care about the
exactly.
function of the
it's the first thing which gets erased, actually.
Yes.
It's the first thing. Yeah. So, when
the programs do not run any faster or better or more clever if you use a particular coding style.
Exactly. So, but we can zoom out a bit. So a code review is basically there to verify that the process to create the code is correctly applied and that we didn't leave anything on the table. And for many kinds of changes I do in my consulting, it's simply way too costly to fuck up. And so the reviewer is basically just there to also sign off on it, like any kind of heavy machinery where you need a signature of your foreman to unload this multi-trillion-dollar thing. This is what a code review is for me. So he has to be able to fast track rerun the entire decision tree and make sure that it was correctly applied.
Mm-hmm.
And the more tool assist we get, the better.
Yes. How's the you did mention a couple of tools or like the state of the tool landscape, but are there any other tooling that you wish to have on everybody who's reviewing the code to have on their toolbox?
I think these kinds of, let's say, semantic reduction chaos monkeys, everybody should have it for every language.
Mm-hmm.
So just make sure. Sometimes you can even accept, okay, we do not cover that one, but I acknowledge we do not cover that one. That's already a big step, because then you can, as a reviewer or as the owner of the software, say, I'm not investing into the test case, but we double review this one where we still have the wiggle room. That is actually going correct. This is also fine, but at least we get pointed to the ones where we didn't do it by the book, because we just have to whitelist, because there is no time right now. Okay, so we had, let's say, hypothetical scenario. There's this giant 50-line method for authentication, applying rules and everything. And we do a one-line change there. And all the tests still pass. Nice. The mutation testing tool obviously goes crazy, like, oh, this was never tested. I've got 300 alive mutations. And you decide, I'm not going to cover all this. That's fine. But at least the tool made sure that this line of code, which triggered a change in this method, which has that many alive mutations, causes that we triple check this specific line, despite the fact we are not going to fix them this cycle.
Yeah.
So it directs your attention. So you can even later say, let's say it was a 100-line change in the diff you are about to review. One line hit this really bad method which has zero coverage. You decide to not cover it, but you can at least use this tool's freak out on this method as a big signal to check this one out very, very thoroughly.
Yeah.
Anybody who would try Mutant, just check out this specific library. We can put it into the description. It's open source. Mutant is pre-installed. You can play around with it. That's a nice way to start. Another topic, SQL.
Mm-hmm.
The more I work with businesses, the more I realize that the core technology is actually how efficiently you interact with the database. And I'm right now toying with the idea to actually make a mutation testing tool for SQL, which also actually means that you need to have a testing tool for SQL, but I already made it. So, yeah. And the testing tool for SQL has an interesting story. So originally we started to use more views and server-side logic, and we tested everything from the host language, either Ruby, Haskell, or whatever I was working with at that time. But over time, you see an interesting kind of drag, because SQL nicely compounds. So it's a very verbose language, but once you start layering complex views, the verbosity, so this 5 lines you just wrote to join left and right, triggers so much logic that you do not care anymore about the verbosity of SQL. We actually think, oh my God, it's nice that it's that verbose to make sure we do not screw this up. And as soon you have a big enough SQL testing corpus, and you start to add one column to that specific relation, which is at the bottom of everything, and this bubbles up to 500 test cases, and then you deal with all these literal expectations you have in your code base, like these arrays or whatever, however you present the relation in your host language. This gets into a giant nightmare. And we struggled with this for half a year till I by accident checked out the PostgreSQL source code for something and tried to play around with it. And I found that they are using mostly golden tests for lots of their more higher level stuff. The low level stuff has unit tests, but the higher level stuff has golden tests. So we wrote a golden testing framework for SQL, which is not beholden to the PostgreSQL testing process, which does some tricks for parallelization and so on. Lots of lessons learned from Mutant here, because Mutant also does parallelization. And it helped us a lot to rely on more complex views. So in certain situations, we got it as far as that we could read the entire JSON blob to render the entire card in one SQL route statement, applying all the current pricing, applying all the triggered promotions and so on. And yes, it's more load on the database, but it's way more load to open a transaction and send 20 to 30 individual SQL statements and piece it together in memory. So, this was a really nice revelation for me in the last 2 years, that how powerful SQL actually is. And Ruby or Haskell I use right now, it's mostly the way to connect SQL to the world, but it doesn't do much logic anymore.
So what do you think if it's such an, and it is a really important part of many applications and systems, the SQL. Why do you think it has received so little love in this area?
I actually think it has received so much love, but I think that many people got sucked into the vortex of CRUD apps and never learned that if you have a pure CRUD domain, then you can use a pure CRUD framework. But as soon as you leave that space, and all the business value is typically outside of the CRUD. So in the early 2000s, you could do a CRUD and make $1 million within 5 seconds. But this is all gone. So all value in software is created from combining data which was written at different times to the system. So an IP packet is worthless, a routing table is worthless, but an IP packet with a routing table, that's value. And the same goes for any kind of, look at an e-commerce. You have your inventory. It's relatively boring, but as soon as you put an order against that inventory, there is where the value gets created. So it's always combining values which have entered the system at different point in time. This is where the business value comes. And there is lots of development on the SQL and database side, but I think that many developers simply got caught up in this vortex of quick, dirty CRUD apps and never looked beyond, because they think the ORM is enough. And the ORM is enough if you have a really good CRUD domain, but most domains are not. So CRUD inherently just reads the data back as you has given it. So this is just a remote key value store, a little bit more sophisticated. So, but this is excluding the value generation path I was alluding to. So, yeah. And I think SQL is way more popular than Ruby.
It is, yes.
It's just, it works so well that nobody writes blog post about it. So it's also not the perfect language. So the relational algebra is so much nicer than SQL. But again, I do not care. I need to accept that I cannot code in relational algebra. I need to code with SQL and its back algebra. Okay. But at least there I can try to do a good job and do not proactively constrain whatever I write in only having to deal with SQL as generated by an ORM.
Yeah.
So right now, I do apps entirely without ORM, all handwritten SQL. All SQL emitted from the app can only have like 5 statements, and everything over 5 statements needs to move to a server-side structure as a view or a function with dedicated SQL tests. And the next thing I would like to do is a SQL mutation testing engine.
That sounds very exciting. Is it really on your high priority list, or when can we expect to see something?
I do not know. So I'm very busy on the commercial side of things, and whenever I have got a little bit free time, I spend it on Mutant. But I think the SQL mutation testing thing will be a Mutant extension. So I recently found a good SQL parser which I can use, and also has a good unparser. So we will see. I originally experimented with doing a C plugin for PostgreSQL to reuse the PostgreSQL AST, but I never got it to finish. It's a different topic. So it's quite fun because you would have to reflect the type struct, the structs in PostgreSQL, and then generate a walker on it, simply because handwriting it would take too much time and also too much maintenance time. I got it to a proof of concept, but I do not think I will finish it. So I will use the standalone SQL parser I found.
Okay, sounds good. Now if we wrap up this discussion, what do you think is the we all did talk about the axiomatic way of development, and do you think that's the what would be your one advice for anybody listening to get on that path, or like get if they want to improve something for the next 3 months in their development teams? What would be the one guiding thing that they should do?
Look at every level of your decision making and always ask yourself, am I using a primitive which has a power I'm not using? And can I use a simpler primitive instead till I actually need that extra power? It's a very simple way to locally reduce complexity. And then if you combine lower complex things, you always build lower complex stuff in aggregate. And if this conflicts with your style, then you found a really nice personal growth opportunity.
That's a very, very well put and a good way to close this episode. So, Markus, it's been a great pleasure talking with you, and thank you for joining.
Thank you for the time. I had more fun than the audience probably. Okay, thank you.